In this lecture, we are going to learn about a very famous problem known as Tower of Hanoi. This is one problem that is always taught to the beginners of any C or data structures program when they are being taught recursion, because this is such a famous problem that you cannot leave it, okay, and it is going to come in your exams, in your interview, everywhere, okay, and it's very interesting problem. So let's see what it is. So we have three pegs, okay, so these are pegs. So this is peg A, this is peg B, and this is peg C. So these are pegs where you can keep some disks, okay. So this is source, this is destination, this is intermediate. So we have three pegs A, B, and C, and we have on peg A, which is the source, so we have some disks, okay. So here we see we have 4 disks. So this is disk 1, this is disk 2, this is disk 3, and this is disk 4, okay. So what we observe is that there are n disks, okay, numbered from 1 to n, and the property is that disk 1 is the smallest, disk 2 is larger than disk 1, disk 3 is larger than disk 2, and one disk 4 is the largest, okay. So it's like so. And now what you have to do, and the property is for these disks is that you have to put smaller disks on the top or above the bigger or larger disks, okay. So 1 is smaller than 2, so it is above 2, 2 is larger than 3, is smaller than 3, so you keep 2 above 3, and 3 is smaller than 4, so you keep 3 above 4. So it cannot be like you can place 4 above 3, so it can never happen that 4 is here and something like 3 is here. So this is not balanced, okay. So you have to keep so that the peg disks are balanced. Now the problem is that you have to move these disks from source or peg A to peg C such that in all the intermediate steps also you always have the larger disks below the smaller disks, and you move only one disk at a time, okay. So let's try to see the problem with one example. So we will try with, let's say, first a very small example of 2 disks, okay. So this is 2 disks are there, 1 and 2, okay, and this is A, this is B, this is C, okay. These 3 are the pegs. So now what we do, so we have disk 1 and 2. Disk 1 is smaller than 2 and it is placed on peg A, okay. So now we have to move these disks onto disk on peg C. So what steps we will follow? So first I will say that, okay, move, so disk 1 from A to B, okay. So we will do that. So 1 is removed from here and we keep it on B, okay. So then what happens, now A is here, so now we move disk 2 from A to C. So disk 2 comes here, so move disk 2 from A to C, okay. And then what I need to do, just move disk 1 from B to C, okay. So something like this. So move disk 1 from B to C, okay. So this way we are done, okay. So now what happens, so we are done and we have in 3 steps I could move two disks from source peg A to destination peg B, and we used destination peg C using B as an intermediate peg. Okay, now let's try the same problem, okay, for three disks. So let's try to do the same problem for three disks now. So again we can imagine that, okay, this will be much more difficult. So there are three disks, 1, 2 and 3. Okay, so now what we need to do, so again let's try first. So it will be move disk 1. So what can we do? So first we will try to put disk 1 and 2, so something like this. So put disk, we have to place 1 and 2 on B, so this will be, so I will place 1 here. Okay, so 1 comes here, so it goes away from here, and then what happens? Then what happens is we put disk 2 on B. Okay, so this comes here, and we have now like the configuration like this. So then what we can do, move disk 1 from C to B. Okay, so move disk 1 from C to B, so it comes here 1, and now we have something B. We moved two disks 1 and 2 from A to B. Okay, so this required us 3 steps, as you could have counted. So now what I want to do, so move now disk A, disk 3 from A to C. So what I do, A to C, I move disk 3, and then here it is gone now. So now what I do, I want to move these two disks on this one. Okay, so what I need to do, so I have to place these here. So I put disk 1 here, okay, and remove it from this one. So 2 steps are gone now. So then what I do, so then I move disk 2 from B to C. Okay, so disk 2 comes here, so it is gone from here, and now what I do, so move disk 1 from A to C. So we move from disk 1 from A to C. So it is something like this, and we have disk 1. Okay, so this requires, if you had counted, so this required us 7 steps. Okay, next what can I ask you, that okay, now if we have something like 4 disks, okay, so if we have 4 disks, 1, 2, 3 and 4, so how many steps would it take? Okay, and how will you do that? By maintaining that, okay, smaller disks are above the larger disks and moving one disk at a time. So now I'm not going to do it, but we now have to think how we should make the computer do this work for us. Okay, so what we see is that, so to move disks from peg A to peg C, to move in fact n disks from peg A to peg C, what we need to do is something like this. So these steps should be taken care. Okay, so, and this was followed by us also. So move n minus 1 disks from peg A to peg B, okay, using C as intermediate peg. Then move nth disk from peg A to peg C. Then move the n minus 1 disks from peg B to peg C using A as intermediate. Okay, So let's see, it is very important. So what we are doing, we are saying that okay, moving n disks is a very difficult task. It's not an easy task that we can do simply. Okay, so what we need, then we need something like divide and conquer. Okay, make this problem smaller size and do it, and then try to reconstruct the solution for the larger problem for it. Okay, so what I say, or what is the solution, is that move n disks from peg A to peg C, first try to move n minus 1 disks from peg A to peg B. Okay, so what it means, so let's try to solve. I know that okay, we solved for 3 pegs, we could solve the problem. Okay, so I know the steps. So now what I say, that okay, we need to solve it for 4. So what I will do is, now we already know the solution for 3 pegs, 3 disks, how to move them from source to destination. Okay, and we said that okay, we have one is source, one is destination, and another one was intermediate. Okay, so now we will use that property, and let's see. So move n minus 1 disk, so 4 are there. So now let's try to just see the problem state, what we had the solution like. So move n minus 1 disks, so move 3 disks from source A. So now I move it from A to B. Okay, so what happens, I move these disks here, so 1, 2 and 3, using C as intermediate. So now what happens here, these 3 are gone. Now what it says, and this can be done, because why I'm saying that okay, this can be done, because we had already said that okay, we solved the problem that okay, there were 3 pegs A, B and C, 3 pegs, and I had 3 disks and moved them from A to C using intermediate peg B. So same thing I can do. So now if I make B as the destination node and C as the intermediate, then it doesn't make any difference. That can be done. So that's what I do. I move these 3 disks from peg A to peg B, and I use C as the intermediate peg. So this is done, and all the time I can just imagine that 4 was not there because it is the largest. So whatever configuration I can keep 3 here, 2 here, so all of them will fit because 4 is the largest. So if I move here the n minus 1 disks to B, then what I need to do, so I have the solution that I know that okay, n minus 1 disks I can place from source peg to destination peg using one intermediate peg. Okay, that thing I already know. So that's what I did. So I moved n minus 1 disk, which is 3 disks, from A, which is the source, to B, which is the destination, using C as the auxiliary or intermediate peg. Now what I do, I move A to the disk 4 from A to C. So disk 4 comes here. This can be done, there is no problem. I move disk 4 from A to C, and that can be done in one step. Okay, then what, now I already know that okay, I can move n minus 1 disk or 3 disks from source peg to some destination peg using another peg as the auxiliary peg. So now there are 3 pegs, and I can move these 3 pegs from source, which is B, to destination, which is C, using peg A as the intermediate. Okay, and again the same logic, that because 4 is the largest, so whatever disks I place here, so they will follow the property that okay, smaller disks are above the larger disk. Okay, so now move n minus 1 these 3 disks from source, which is B, now to destination, which is C, using A as the intermediate disk. Okay, so this is now done. Okay, 1 2 3 4, and that is how we solved this Tower of Hanoi problem. So the code basically will be the same. So if you have to write this code, so to move, so that is, so we will again see with a simple example. So with 2, okay, so we will try it first with 2. So what happens? So 1 and 2, this is peg A, this is peg B, this is peg C. Okay, and what we need to do, so the steps that we follow are, so I move, so move n minus 1 disk. So for this what I do, I can place like this, that okay, 1 comes here in the step 1, so move disk 1 from A to B. Okay, then move 2 from A to C, then move move 1 from B to C. Okay, so first what happened, so this was there, I moved 1 from here to B, so this was cleared. Then I moved 2 from here to C, so 2 comes here, and everything goes from here. And then what happens, I move 1 from B to C, so it comes here and this becomes empty. Okay, so this is the thing. Now what? So now the same thing we have to do with 3. So because now in these 3 steps I know how to move now 2 pegs from some source node to some source peg to some destination peg, and we used B as the auxiliary peg. So it means that okay, if 3 pegs are given, I can move 2 disks from source peg to destination peg using another peg as the intermediate peg. So if we have a problem consisting of 3 pegs now, 1 2 and 3, so we can very easily now move, because I know how to move 2 pegs. So I will do what, move these 2 pegs from the source will be now what, the source is A, and I want to move them to B instead of C. So what I have to do, so I will use B as the destination and C as the auxiliary. So I will do, first step will be, so move 2 disks from source is equal to A to destination equal to B, and auxiliary we will use as C. Okay, so this way now what happens, the 2 and 1 goes away, and now they come at this place. Okay, 1 and 2. Now what we do, so move disk 3 from source is equal to A to destination equal to C. Okay, so this can be done without any auxiliary peg. And what happens, so this is gone now and it goes here, so 3 comes here. Then what, move, again I know how to move 2 disks from a source peg to destination peg using one auxiliary peg. So move 2 disks from source is equal to B to destination is equal to C and auxiliary is equal to A. Okay, so this way now we move from this to this using A as auxiliary. So what happens, these two are gone now and they both come here. Okay, so this requires a 7 step. And why 7? So let's see the time complexity. So let Tn be the time complexity, Tn be the number of steps required to move n disks from source peg to destination peg, okay, using auxiliary. Okay, so this is the Tn is the number of steps. So then what happens, what we can say is Tn is consisting of what, moving n minus 1 disks from source peg to destination peg. Okay, so move n minus 1 disk from source peg A to peg B using C as intermediate. Okay, so this requires again, so Tn now becomes equal, it consists of 3 steps. So first step is move n minus 1 disks from peg A to peg B using C as auxiliary. So it will be equal to Tn minus 1 plus moving nth disk from A to C, so 1, plus moving n minus 1 disk from B to C using A, B to C using A, so it is Tn minus 1, which is equal to twice Tn minus 1 plus 1. So this becomes the recurrence relation. So Tn is equal to twice Tn minus 1 plus 1. So if you solve this, so Tn equal to twice Tn minus 1 plus 1, so this is equal to 2 square Tn minus 2. So this will be what, so twice into Tn minus 2 plus 1, so this is 2 square Tn minus 2 plus 2, then we can write it as 2 square twice T of n minus 3, okay, and plus 1. Okay, so if you keep on doing like this, so it will be 2 to the power of n minus 1. Okay, so Tn is 2 to the power of n minus 1 if you solve this recurrence relation. So you have to take care how it is happening here, you just expand this. So we saw also for n is equal to 2 we required 2 square minus 1 equal to 3. For n is equal to 3 we require 2 to the power of 3 minus 1 equal to 7 steps. For 4 you will require 2 to the power of 4 minus 1, which is 15. So it will be 7 for one n minus 1 move, then for another n minus 1 move it is 7 plus 1, so it is 15. So I hope you understand now what is Tower of Hanoi problem and how to solve it recursively.